Alright, this video is to help show the relationship between the mass and the number of moles of a substance. As a review, when we talk about molar mass, it's the mass of 1 mole of a substance is measured in the unit of grams. Let's take a look at this example. Alright, it says find the mass of 1 mole of a substance. When you have 1 mole of a substance and you're looking for the mass, that just basically means calculate the molar mass, and you should already know how to do that. Remember, it's fairly easy, but take a look at that thing. You need to know what that thing is. Alright, so if it was given the name, you need to know how to write the formula. That is potassium, alright, chlorate. Okay, and because that's K, and that's ClO3, that's chlorate, so it's potassium chlorate. Alright, let's go ahead and let's find the mass of this. So you need your periodic table for this, because that's what has the atomic masses on it. So you say, alright, there's 1K, I'm going to multiply it by its atomic mass, which is 39.1 grams per mole, and that equals 39.1. We have a chlorine. There are one chlorine. Multiply it by its atomic mass, which is 35.5 grams per mole, and I get, shockingly, 35.5. And then we have some oxygens here. We have 3 oxygens in the formula. Okay. We multiply that by oxygen's atomic mass, which is 16.0, and I get 48.0. All we have to do is add those up, and it looks like we have 122.6 grams per mole. And that is how you calculate the molar mass, my friends. It's fairly easy to do. Please make sure you ask for assistance if this is confusing right now. Alright, so the reason why we need to be able to convert between mass and the number of moles is oftentimes when we do experiments or labs, you're trying to find liters, or trying to if you have the mass of one substance, you're able to get to the mass of another substance, or volume, or number of particles, using the mole relationship. And we will get practice with that. But right now we're going to talk about how do you convert between the mass and the number of moles, and that's going to be fairly easy. That's basically just using the molar mass. Alright, now there is an equivalence that we have, because since the molar mass equals the mass of 1 mole, you basically have 2 things. You have the molar mass, alright, divided by 1 mole of the substance, or you have 1 mole divided by the molar mass of the substance. Alright, we're going to use this relationship right here to help us convert to different units. Let's take a look at example number 1. Alright, so right here we're going to be converting from moles to mass. Now, if you're handwriting your notes, what you basically need to do for this example is just write what's in red. Alright, the black part's just extra stuff. Alright, so it says aluminum is resistant to corrosion because it reacts with oxygen in the air to form aluminum oxide, which is Al2O3. Alright, this coating on the aluminum prevents it from being corroded any further. What is the mass in grams of 3.26 moles of aluminum oxide? Now, if I did not give this formula to you, you need to be able to know how to figure out what is that formula. Just remember, aluminum has a +3 charge, oxide is O with a -2, cross your charges, and that is Al2O3. That's how I got that formula. Okay, there's nothing tricky about that. Since this is aluminum is a metal, it's ionic, you write the ions down, cross your charges, and you get your formula. Now, the first thing you need to have when you're converting from moles to mass or mass to moles is the molar mass. So that is what we need to do. The first thing is let's find the molar mass of aluminum oxide. Alright, so we know in my formula I have aluminum and I have oxygen. Alright, there are 2 aluminums present, 2 aluminum atoms in this formula. So I multiply aluminum by its atomic mass, and you look in your periodic table, the atomic mass for aluminum is 27.0 grams per mole. For each oxygen, since there are 3 of them, each one has a mass of 16.0 grams per mole. So I take 2 times 27, I get 54.0, and 3 times 16 is 48.0 grams per mole. I add these up, I get 102.0 grams per mole. So that is my molar mass for aluminum oxide, 102 grams per mole. Now, let's go get into solving the problem. All right, so remember, when you do a dimensional analysis problem, it's just basically what this is. We're just converting units, which we did back in August and September. You start with the number you have and you put it over 1. Now, you don't have to put it over 1, but I recommend so you know that that number is on top. So you have 3.26 moles of aluminum oxide, and I'm going to go ahead and put it over 1. Now, let's go ahead and let's multiply it by our conversion factor. The conversion factor we have is the molar mass divided by the mole, or the mole divided by the molar mass. Now, since I have mole up here, I need mole to cancel out. So if you have something in the numerator, it has to cancel in the denominator. So mole goes down there of aluminum oxide, and that means that's what I want. I want it to go bye-bye. And I have grams up here because that's what I'm looking for. Okay, so how you do this is you say 102 grams per mole. So what this really means is there is 102.0 grams of aluminum oxide for every 1 mole of aluminum oxide. Alright, so that's what that means when you talk about the molar mass. Okay, so I'm going to go ahead and put in my 102.0 grams right there, and we have 1 mole. Now all I have to do, since my units cancel out and I'm left with grams of aluminum oxide, that's the unit I want because it's asking in grams, what is it? All I have to do is do my math. Since these numbers are both on top, I just simply multiply. So I take 3.26 times 102.0, and I get this number right here. I get 332.52 grams, but I need 3 sig figs for my calculation. Here there's 4, here there's 3. So my answer needs to have 3. So I'm going to cut it off right there, and since this is a 5, that 2 rounds up, so my answer is 333 grams of aluminum oxide, and that is my final answer. So in essence, what you do is, if you're converting from moles to mass, you simply just multiply by the molar mass. Okay, that's essentially it. So if you have moles, just multiply by the molar mass, and that's all you have to do to get to the number of grams. Alright, let's take a look at example number 2. Example number 2 is going the opposite. We're converting from mass to the number of moles. Alright, so it says iron reacts with oxygen to form iron 3 oxide, which is a red-brown substance known as rust. And there's a picture of it right down there. We want to know how many moles of iron 3 oxide is in 138.5 grams of it. So let's go ahead and let's first of all figure out what is the molar mass of iron 3 oxide. So iron 3 oxide, Fe2O3. Alright, so we know we have an iron and we have oxygen. There are 2 irons present, 3 oxygens. We know that 1 times 16, missing out some numbers, times 16.0, which is 48.0. We just did that one, so that's why I did that one so quickly. And let's take a look at iron. Alright, take a look at your periodic table, and iron's atomic mass is 55.8 grams per mole, and when I take 2 times 55.8, I get 111.6. All I gotta do is add these numbers up, and I get 159.6 grams per mole. Okay, so that is my molar mass. Let's go ahead, let's change colors a little bit. I'm feeling brown today. Alright, let's pick brown since we're working with rust. It's a brown color. Alright, so we want to know how many moles of iron 3 oxide are in 138.5 grams of it. So remember, what you have in your problem, you start with that number and put it over 1 if you want to. So we're at 138.5 grams Fe2O3. Put over 1. And let's figure out what type of math we have to do here. Now, I have grams in the numerator, so I have to get rid of it because I don't want grams, I want moles. So, grams has to go down here, Fe2O3, and I want the number of moles of iron 3 oxide. All right, so remember what this means right here. When you take a look at this, that means it's 159.6 grams of Fe2O3 divided by 1 mole of Fe2O3. That's what the molar mass means, and this is what allows us to get that conversion factor. So what happens is, with using the molar mass, you can actually flip this around or invert it to solve for what you need. So basically, if we have grams up here, we're going to have the grams down here. So I'm going to put, for every 1 mole of this, there's 159.6 grams of iron 3 oxide. So now if you take a look at this, let's pick red to go with the rust theme, that cancels out, and that's what I want. So what I'm going to do here is I'm going to take 138.5, and since it's on top, I'm going to divide it by this on the bottom. So I take 138.5 divided by 159.6, and that will be my answer. Now, my answer is going to be rounded to 4 significant figures, because there's 4 here and there's 4 right there. And when I divide this, I get an answer rounded to 4 significant figures of 0.8678 moles of Fe2O3. And that is my answer, which is this stuff right there, rust. Alright, and that's it for today. If you have any questions, please make sure you contact myself or Mr. Kleinschmidt. You can email us, you can call us at our extension at school. Do whatever you have to do, but try to make sure you do this and you do your homework as well to make sure you're successful in our class. If not, you're really going to start struggling.